The Sun is estimated to be 4.6 billion years old and is mainly composed of hydrogen, helium, and trace elements. The core is the central region where nuclear fusion occurs, converting hydrogen to helium. Radiative zone is the region where energy is transferred mainly through radiation. Convective zone is the outer layer of the Sun's interior where heat is transferred through convection. Photosphere is the visible surface of the Sun. Chromosphere is a layer above the photosphere visible during solar eclipses. Corona is the outermost layer which extends into space and becomes solar wind. The temperature of the photosphere is 6000 degrees Celsius, whereas the temperature of the corona is 1 to 3 million degrees Celsius. So basically the temperature of the corona is hotter than the photosphere, and this is an area of ongoing research. The Sun has a magnetic field of its own which is very complex and variable, affecting not just the Sun but also the entire solar system. The solar cycle is an 11-year cycle where magnetic poles reverse. This cycle correlates with the number of sunspots, solar flares, and other solar activities. Sunspots are dark spots on the Sun's surface, regions of intense magnetic activity. Solar flares are sudden releases of energy triggered by magnetic reconnection. Coronal mass ejections are huge eruptions of plasma and magnetic field from the solar corona. Solar wind is the continuous flow of charged particles guided by magnetic field lines. As these charged particles from the solar wind approach Earth, they encounter Earth's magnetic field. The Earth has its own magnetic field similar to a giant bar magnet which is generated by currents in its molten outer core primarily made up of iron and nickel. Instead of moving straight towards Earth, these particles spiral along the magnetic field lines. Most of these particles are guided towards the poles due to the structure of the magnetic field of the Earth. This interaction creates a region around Earth called the magnetosphere. The front boundary facing the Sun. The front boundary facing the Sun is called the magnetopause, where the pressure from the solar wind balances the Earth's magnetic field. It acts as a shield, deflecting most of the charged particles away. Sometimes the Sun has outbursts called solar flare or coronal mass ejections, which can result in a stronger, more concentrated solar wind. These can create disturbance in Earth's magnetic field called geomagnetic storm. The increased radiation from geomagnetic storm can pose a hazard to astronauts and satellite technology. This can also affect high-frequency radio communication and may also affect the accuracy of the navigation system. Geomagnetic storms can induce electric currents in power lines, potentially damaging transformers and other components. When these charged particles interact with our atmosphere at the poles, they create dazzling auroras. Imagine a world where the Earth had no magnetic field. This isn't just about the absence of a force we learned in physics. This change has profound consequences for life as we know it. Without a magnetic field, there would be no magnetosphere. The magnetosphere, as we have previously discussed, acts as a protective shield around our planet, deflecting the charged particles from the Sun. But in this hypothetical scenario, with its absence, the barrage of the Sun's radiation would have direct access to Earth. This constant bombardment by solar radiation would start to thin out our atmosphere over time. The atmosphere, as you all know, plays a pivotal role in maintaining the Earth's climate, and it also acts as a protective layer against harmful cosmic and solar radiation, especially the ultraviolet radiations. But what happens when this atmospheric shield weakens? For one, the protective layer that shields us from harmful UV radiations would diminish. Direct exposure to increased UV radiation does not just mean severe sunburns, it means direct damage to the very building blocks of life, our DNA. Mutation in DNA can lead to catastrophic health issues, including an increased risk of cancers. And if we think long term, our blue planet, with its vibrant life and diverse ecosystems, could start resembling Mars, a barren, cold desert with a very thin atmosphere.